Hello everyone, welcome back. In this third video, we will demonstrate a program to compute greatest common divisor using the Euclid algorithm with a program. As we have discussed in previous two videos, we have used the data processing, that is the add, the subtracting, this kind of arithmetic commands. We have also used the LDR or STR, store, load, this kind of data transfer commands. Now we are using the branching. Branching is so important in computer programs. With branching, we can program relatively complex functions with relatively intuitive ideas. So, as we have talked about something about branching in class, um, it is very straightforward that if we try to use branching, we will try to branch to different locations in a program. That will lead to different subroutines in the program. We will also use that in our function. So let's look at the program. One tricky thing is that in order to load the to load the two numbers into two registers, we use the R0 and R1 here. We actually use the LDR command. Someone might wondering, we can use the move command to execute on the immediate value, so why we don't use it? One tricky thing I want to show you here is that actually we can use the move to load this kind of immediate values. However, we mainly use it for the small numbers less than 256. For numbers larger than that, it might cause some error. For example, if we do not use the load, we use the move to load these two relatively large numbers. ARMSIM just returns an error. The program cannot be run at all. So if we try to use the move, we have to keep the source numbers small. So if we try to use these two numbers, that would be okay. Load. Oh, no, that's okay now. So that is one tricky thing I want to talk about when we are trying to load numbers, when we are hesitate between the move or load. So now let's look at the structure of the program. First part is the initialization. Of course, I have talked about this. Using the move or load, you have to choose one. And then you get the two numbers. You go into a loop. As we know, the Euclid algorithm keeps subtracting each other until two numbers become the same, and this remaining number would be the greatest common divisor. This is a very simple idea, but we need to use loops to realize it. So this involves branching. We compare the value in R0 and R1. As we have discussed in class, they will compare with each other. If the R0 is larger than R1, that is in our program here, then the flag will be, the negative flag will be remain 0. However, if the R1 is larger than R0, the negative flag will be set as 1. That means R0 is smaller than R1. We can run this program step by step to see the value. Okay, so now R0 is less than R1, and now the flag, negative flag, becomes 1. And of course, they are not equal. If they are equal, the branching will cause it to jumps to the end of the program. So they are not equal. Now they compare. Yeah, when this negative flag is 1, that means it will use this BRE command to jump to the subroutine of less this part. So we are subtracting the small number from the larger number. And then jump back to the loop to continue until they are equal. Yeah, this time the R0 position number is larger than R1. I will run this. Yeah, we can see that the two numbers keep decreasing. Yeah, R0 and R1 both becomes 12 and they are equal now, and the program goes to an end. And 12 is the result we want to get. I know that right now I'm using the move to just compute the greatest common divisor of two small numbers, 72 and 132. To compute larger numbers, we still need to use the load command. I will change it and show one time to you. Of course, to keep the program healthier, I would suggest just using the load command. Unless you are very sure you will not compute numbers larger than 256. Flags are changing, keep changing, and oh, I accidentally pushed the reload. Yeah, now the result becomes 21 is our final result. Well, even though this is a very simple programs, it can show some elements of a full long program. It has the branching and loop, and it uses some subroutines. So, and finally, I still need to remind you of this tricky thing when you are trying to uh, executing the immediate values using these two different commands. Okay, that's all. Thank you.